So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily challenge of minimum number of operations to move all balls to each box. So in this problem, we have to given a binary string and also we have to given boxes of I which contains 0 and 1. The the 1, the 0 represent empty and this 1 represent the ball is containing on that box. Okay, and we have to find here we have to find move one ball to another adjacent ball at index. We have to checking their adjacent element. This is our value, let's suppose, and we have to finding their adjacent of I minus 1 and I plus 1, so that we have to finding their move one ball to another ball and finding their adjacent box. Okay, so in one operation basically, and our goal is to answer of I. Here the answer of I represent the total number of operations required to move their ball to one position to another position of boxes of box of I. Okay, so our general idea for that question is basically, our general idea is our box of I. Let's suppose our box of I is calculate the total number of operations required to move all balls to ith position. Okay, we are discussing their example test case, so that you have clear that question statement, and also we have to involve this absolute difference of I minus j for all position where the ball of boxes of j is equal to 1 is present. Okay, so this is the conditions we have to given and we have to take care for their programs. And so now let's discuss their first example, so that you have to clear their statement what they are saying. And first we have to given boxes. This is length of 3. Okay, and so we have the positions of balls and to find their adjacent ball. Basically, in our first example, 110, 110. Okay, this is our string, binary string, and the ball at j is equal to 0th position of box of 0 is equal to 1. So basically here 1 is present and ball at j is equal to 1 position, box of 1 is equal to 1, and this position we have no any balls and no any balls are present, so that's why we have only two balls are there. So we have to calculate each and every operations for each box of I. Okay, so now let box of 0 box of 0, first we have to move the ball from j is equal to 1 to I is equal to 0. So basically j is equal to 1. Okay, j is equal to 1 to 0, I is equal to 0. Okay, so j is equal to 1 to I is equal to 0. We have here what we getting 1 minus 0. We have to finding their absolute difference. Also the question statement is also saying absolute difference of I minus j. Okay, and here the absolute difference of this is 1. We have to number of operations is 1, the total operations here. Okay, and we have another box of we have another box of 1. Here our position where ball is present, j is equal to 0. Okay, the j is equal to 0 to I is equal to 1. Okay, and here the operations are absolute difference of 0 to 1 is equal to 1, and this is our difference And after third operation, our box of 2, we move the ball j is equal to 0 to I is equal to 2, because of we have calculating these two again and again, but now at that time this one operations, this first operation we have performing to this operation and this operation. Okay, so now 1 1 0, so we calculating I j is equal to 0 and I is equal to 2. Okay, j is equal to 0 and I is equal to 2 of absolute difference of 0 minus 2 is equal to 2. Okay, and next operation we have the ball move the ball from j is equal to 1 to I is equal to 2. So basically here we have getting 2, so I is equal to 2 value is updated here. Okay, first I is equal to 2 value is 1, but this time the value is updated, so this value is 2, and the absolute difference of this j is equal to 1 value is 1, 1 minus 2 is equal to 1. Okay, and after total operations we have getting here 2 plus 1 is equal to 3. So these are our operations to performing all kind of stuffs, and we have to getting here 3, like what we are getting here last operation we have to getting 3, 1 1 and 3. Okay, and one more example we have here, we also discussed this example. So basically uh, where the balls are presented, like we have given string is 0 0 1 0 1 1, and this is our 0 1 2 3 4 and 5. Okay, this is our index value, and after this we have here where the ball is present. First j is equal to 2th position, and j is equal to 4, and j is equal to 5. These positions are here there to present their balls basically. Okay, and after operations we have box of 0 box of 0, we have calculating their operations. So ball at j position is difference of 2 minus 0 is equal to 2, and ball at j is equal to 4 minus 0 is equal to 4, and ball at j is equal to 5 minus 0 is equal to 5. So the total number of operations are 2, 4 and 5 is equal to 11. So these are number of operations to performing on that case. So we are getting here 11, and next operation we have here one box of 1, and same operation we are performing here, ball at j is equal to 2, ball at j is equal to 4, and ball at j is equal to 5. And the we our position is now this first index. Okay, so the operation of absolute difference of this 2 minus 1, 4 minus 1 and 5 minus 1. Okay, 2 minus 1 1, 4 minus 1 3, 5 minus 1 4. This total number of operation is equal to 8, and we also performing all these operation to one and another operations. So the next operation we have box of 3. The box of 3 is same things we have performing here, and here is 3 minus our index value of that case. So basically, one second, sorry, 2 minus 3 is equal to 1, absolute difference we have to calculating here, and same thing 4 minus 3 and 5 minus 3. So the here is 1, here is 2, so the total number of operations is 4, And same as box of 4 we have calculating here. Box of 4 is 2 minus 4, and 4 minus 4, and last is 5 minus 4. So this is our 2, this is our 0, this is our 1. So the total number of operation is 3, and same as box of 5. Box of 5. Box of 5. One second. Box of 0, 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, and 5. Okay. Box of 5. Box of 5 is j is equal to, we have also here j is equal to 2, and j is equal to 4, and j is equal to 5. 2, 4, and 5. And we have calculating for our index value. So absolute difference of 2 minus 5, absolute difference of 2 minus 4, absolute difference of one second, 2 minus 5, here is 4 minus 5, here is 5 minus 5. Okay, absolute difference of j minus index value we are calculating here. So here is 3, here is 1, here is 0. So the total number of operation is 4. So now after updating all these positions, we are getting 11, and second 8, and we have here one second, box of 2. Sorry, we are not calculating here box of 2. Box of 2 is j is equal to 2, j is equal to 4, and j is equal to 5. So box of 2 is 2 minus 0, sorry, 2 minus 2, 4 minus 2, and 5 minus 2. Okay, so that here we are getting 0, 4 minus 2 is 2, and here is 3. So the total number of operation is are 5. Okay, so here we are getting 5, and here is 4, and next operation we are performing there is 3 and 4. Okay, 3 and 4. This is what we are want. So we are getting our actual answer. So I hope you understand the logic and the how we can absolute difference are finding, the simple way we are calculating there. And now let's discuss their code and their time complexity. So first we have here also defining n is equal to boxes dot size, which stored the string of boxes, and one calculate and track the cumulative number of balls of one which encountered while iterating through the boxes, and this sum is track the cumulative sum of operations required to move all balls to the, it means it moves all balls to the current box during traversal. Okay, so the vector of answer is store the final result of the minimum operation of each boxes. Okay, and after this we have performing a for loop. This for loop is finding the sum of ones. Sorry, we have finding the ones, and after sum we have to store into our we have calculating one, and after this we have storing into sum, and after this we have push their sum into answer, and after this we have their boxes of I is equal to 1. This condition is basically if the current box contain a ball of 1, so we are calculating here. Okay, where the 1 is present, then we are incremented their 1 count, 1 plus plus. Okay, and next we have, and let's suppose the example we can take here, 1 1 0. Okay, if I is equal to 0, we have presenting there sum is equal to 0 and answer is 1 is equal to 0. If the I is equal to 1 is here, then directly we are 1 plus plus. So this condition is basic condition for to iterating and to checking all these conditions. And after this we have to reset their one and some value, and we have to finding their right right to left position. Okay, right to left position, and we have same operation we are performing, which yahan which on their thing and this thing. Okay, and after this we have directly written their answer to containing minimum number of operations for each box. Okay, so now the time complexity so now the time complexity of this code is this left side, left to right. Okay, this is left to right. Okay, left to right side, this perform O of n operation, and this right to left operation perform O of n time. The total time complexity of O of n plus O of n is equal to 2 O of n is and the total time complexity is O of n because of this is constant. And after this we have calculating their space complexity. The space complexity of this code we have defining their answer vector. So that's why the space complexity is O of n solution. So I hope you understand the video and the logic behind that code. So thank you everyone, thank you so much.